All right, so we're going to look at a question here that involves a hockey player passes a 160-gram puck to his teammate. The puck is sliding 30 kilometers per hour north when it reaches his teammate, who then shoots it back south with a speed of 70 kilometers per hour. And the puck was in contact with the teammate's stick for 0.15 seconds. What is the average force exerted on the puck during this shot? So if we look at this, we're given a few pieces of information: time, mass, and some speeds. And we're asked to find a force. So the force is the thing we want. We're given time. So that is the amount of time that the teammate's puck was in contact, or the teammate's stick was in contact with the puck during the shot. We're given the initial velocity of the puck as 30 kilometers per hour north. And we're given the final velocity to be 70 kilometers per hour south. So completely 180-degree change in direction. We're also given the mass. I'm going to put that into kilograms right away because forces are measured in newtons, and that's all based off of SI units. So kilograms, meters, seconds. So we'll put that into kilograms right away. Let's do the same thing with the velocities. Let's convert those to meters per second. The conversion is dividing by 3.6. So that will give us 8.333. As usual, keeping some extra digits because we're going to keep using these numbers in further calculations. This one would convert to 19.444 south. So we're given information about mass and velocity. Well, momentum is equal to mass times velocity. Now we're asked to find force, so we need a way to relate force and momentum, and that is going to be through impulse. Now remember, impulse, represented by J, is equal to a change in momentum. And impulse is equal to force times the amount of time that force is acting. And change in momentum can be represented as mass times change in velocity. So we can see from here, we have all the information we need. Force is the only one we don't know. So this is the perfect approach. So let's look at it as F delta T. We can write this as mass times V2 minus V1, right? Delta V. So if we actually put those in, it's going to be mass. I'm going to focus on the V2 minus V1 first before I put any of the other numbers in. So V2 is 19.444 south minus 8.333 north is equal to F delta T. F delta T to mass times. So 19.4 south minus 8.3 north. Well, minus north is the same as positive south. So we can essentially add those two together. We're going to get 27.777 south. And now let's sub in the rest of the numbers. So force, I'm going to divide both sides by delta T to get force by itself. So you'll be left with the mass, 1.60 times 27.777 south, all divided by the time, which was given to us as 1.50. And if you crunch all those numbers, you're going to get 29.6 newtons. The direction is still south. And that is your average force exerted on the puck during this shot.